Manipulation 1, data manipulations. Essentially, we're going to do a lot of data manipulations here, and it's going to be really exciting. Your library is your paradise. I like that idea. The more books you read, the more you internalize things, the better you'll be. I like that idea. Many ways. Oh, I have 2 quotes here. Wow. Many ways to the top of the mountain. Choose one. Many ways to the top of the mountain. Know many. That's by me. We'll learn a couple ways of doing the same exact thing. It's nice for you to be familiar with many, but know how to implement. All you have to do is just implement one. Alright, so that being the case, we've actually been working with this particular library for a while now, Tidyverse. And unless you're familiar with R, you wouldn't know that the Tidyverse is just the best package ever, because it houses so many useful other libraries, such as dplyr, which is going to be used for data manipulation, which we're going to learn more about today. ggplot, we're going to learn about making visualizations. Spotify, that Spotify package is made off of ggplot. stringr, we're going to talk about that today. That's huge in terms of working with text data. And tidyr is to make and implement more data manipulations. So we're going to learn about the Tidyverse. Okay? So with that being said, let's continue. Alright, so there is a data frame, empty cars. I'm pretty sure this is our first time using it. It's a pre-made or pre-built or built-in data set or data frame within R already. And so before jumping into dplyr, the data manipulation components, what we're going to do is create a new R. That's from the last video. Create a new R markdown. If you want to use Quarto, that's fine. And I'm going to do help. MC cars. And so this is again a built-in data frame. And the reason why I'm teaching you about help is that you can know about the actual data frame that we have access to. And so when it's a function or when it's a library that's already built into R, you can actually gain more information from the actual data frame. So here we're able to know what the variables are, as well as the number of observations, the number of rows, as well as the number of columns. Okay, so here you have gross horsepower for HP, so on and so forth. Alright, so now with that capacity, what is the variable drat? So you should go here, look at where drat is, and ideally you would have, I won't put kind of fast, but you could read slow on your end. That's the rear axial ratio. Okay? Alright, with that being said, I think we're ready to learn about the select function. Sure are. We are sure that we're going to learn about the select function. So when it comes to the select function, what it does, it allows you to select columns. Okay, it allows you to select columns. And so what you initially do, what you give to it is a data frame, and then you say, what variables do you want? So what I'm going to have you all do is load in that Starbucks data frame. We're going to load in that Starbucks data frame. Remember that CSV file? And we're going to practice getting information from the actual data frame. That get variables from the data frame. So why don't you all meet me in R, and let's see how it goes. You made it. It's like, so when it comes to the actual Starbucks data frame, notice that I'm in the directory where the Starbucks data frame is actually currently residing. So here it is. And so when I run this, I should not get any error. I shouldn't get any errors. I shouldn't get an error at all. Okay, so I didn't. So I read in the Starbucks data frame, and let's say it says 3 variables V1, version 1. Okay? And so it says price, season, timeline. And so what I'm going to do is I'm going to go to my environment and go to where it says 3, price, season, time, and line. Okay? And so select allows you to select variables. Okay? Whereas 2 variables says day of the week in calories. Go here. For 2 variables, day of the week in calories. So it works. Good job. Alright, so we're able to select. So another big thing that we can do with data Why don't you all actually, before I even do the next thing, what you can do with data, why don't you all run this? Why don't you all do these two questions? Alright, so what is the mean price? Use a select function. So here you press select. Oh, that's fun. So notice we use select. We're selecting from the Starbucks data frame. Selecting price. Okay, so that's only one variable, and then we find the mean. Let me tell you something. This is not good looking code. This is not good looking code. Okay, I'm going to show you a way to bypass this. But I'm just letting you know this is not the greatest looking code. Alright, so then what we're going to now do is create a new data frame called PRM temp df. So this is price, I guess, temporary, or temperature, price temperature with only temperature and variables. Ideally you would have done that, and this would have been your functionality. Okay, this would have been your code. Okay, and so if you remember, we can actually double check if this actually gave us what we want. It said season. It's okay, I'm going to ignore that. We could run this, right? And then say column names of PR, temperature, df. And what it gives us is just the column name. Just so you all remember that can happen. So what I was going to talk about that I didn't have the opportunity to do is to tell you some really nifty things that the select function can do, or has the ability to do. Let's say, for example, Starbucks data frame, we want to get rid of a particular variable, like day of the week. I don't know why. Well, we just wanted to. So what I can do is I'll say mod 1. The reason why I say mod 1 is because it's the first modification to Starbucks df, and I'm going to say equals, or I could even do the less than minus, that works as well. Select Starbucks data frame, and I'm going to say minus. Minus is to get rid of, I said day of the week, didn't I? Day of, I don't know why it's not auto-completing. Okay, so if I go to mod 1, you can even just do a quick comparison. This has 13 variables, whereas Starbucks has 14, because it got rid of it. You can see, day of the week is not there. Okay, so that works. Okay, so minus works. There's other things you can do with select, but when we have the opportunity, I'll show you more. Okay, we shall continue. Finally, the shortcut. So many ways to talk about and choose one, many ways to talk about no many. This is another way of doing the same exact thing, but piping it. So what's happening here is that the first argument, ooh, big word, the first argument within select is going to be outside of this thing that we call a pipe. And then we provide the function and the second argument, or whatever other argument that we want. Okay? And the reason why this is nice is because it looks it looks aesthetically pleasing, and you can kind of read what's going on, and you'll see what I mean in a moment. So here, we can copy and paste this into R. As you can see, I'm putting it up here, right next to the original versions. Okay? I can hear it now. I can hear it now. I don't believe you. I don't believe you. So there's a function called all.equal, all.equal, and what I can do is I can do 3 variables version 1, 3 variables version 2, and if it gives me true, that means that it legitimately all the variables are the same, or all the information is the same. So these two data frames, 3 is identical. Okay, so that works. All right. Okay, so why don't you all take a moment and create a data frame called PR temp df1 with only price and temperature, no season variables. Do this using the pipe. Take a moment and do that. All right, so when you do that, this is what it should look like. And you can actually take some time and just confirm it with all.equal. You should do that just for practice. All.equal to double check that these two data frames are the same. It should say underscore df, but that's fine. Let's learn some more. Hey, I'm going to take you back to high school real fast. So you have some math operators. Less than, equal to, greater than, equal to. And in this particular situation, it'll remember that we're comparing numbers. So these operators allow us to compare different numbers. But what's different about it is that it actually gives you a boolean logic. It gives you back boolean logic. Okay, 1 is less than 2. That should be a false. That's not a true statement. 10 is less than or equal to 2. That's a false statement. Why am I doing that? 1 is greater than 2. Then that is a false. Oh, 1 is less than 2. Wow, that's a true statement. 1 is less than 2. 1 greater than 2. That is a false statement. Okay. And so this is important because when it comes to working with data, actually one more operator to talk about, equal. And so in Python it's the same thing, and I think C++ is the same thing. Equal just checks if two things are equal to one another. Okay, so if you run is A equal to A, this should run as, I'm going to put this in the console. Let me just move this down a tad bit. And I'm just going to erase it so you can see it. That is true. But if I say is A equal to small a, that's false. These characters are different. Okay, so that's important in terms of analysis. When I say analysis, what I mean is when it comes to just working with data, being able to make sure these characters are strings or are exactly what we want is going to be really, really important. Okay, so with that being the case, okay, if I run the following in R, what should it return? Is 10 less than or equal to 10? That should give me true. Is apple equal to apple? That is going to give me a false. These two statements are not the same. 40 greater than 4, 40 greater than 10, that is a true statement. Okay. And this is nice. The thing is, what's wrong with this? And the issue with this is because it needs to have 2 equals. It needs to have 2 equals. So make sure you are cognizant of that. Alright. So the reason why we went down that rabbit hole a little bit of the math operators and the equal is because we can start filtering. I got ahead of myself earlier. We can start filtering our data frames. So let's go back to empty cars. So if you go to empty cars, I'm going to say capital V empty cars. Okay, so we have these data frames. We have these variables. Okay, so let's say, for example, at the end of this, what I want to do is say empty cars. Okay, I'm going to pipe it. So that's the first argument within filter. I can pipe the data frame into filter and then say horsepower less than or equal to 200. Okay, and so then it's going to give me all the horsepowers that you see here in this column that are less than or equal to 200. And so what I'm going to do is I'm going to say this is mod 1 because it's the first modification, empty cars df. Okay, and then when I go to mod 1 here, empty cars, I'm only going to get the actual horsepower that's less than 200. I was got confused. 200. Okay, great. The highest is 180. Okay, great. Let's continue. Okay, take a moment and look at these questions. Go ahead and try them. I can't believe I actually walked away. But write the code to only displaying cars where the MPG is greater than 20 or greater than or equal to 20. Save. Do not save the data frame. Okay, so miles empty cars pipe. It should be the next line. I don't know why I didn't do that. And then filter miles per column greater than or equal to 20. Okay, create a data frame where the car's VS. So VS is a variable is equal to 0, exactly equal to 0. Save this data frame using an appropriate name. So this is me trying to teach you all to use appropriate names when it comes to working with data frames. Okay, and then find the number of rows. This is us running it. But I'm actually going to take a moment and run this code. and actually show you another nifty way of implementing this. So like there's something called end row. And this should be called df. I don't know why that didn't happen. And then I'm gonna use end row. So end row should tell me the number of rows, 18. Whereas end call is going to tell me the number of columns, 11. Okay, so a little fun, some fun functions. All right, so continuing on, filtering with multiple conditions. So I'm going to teach you all this concept called and. This is ampersand. And so ampersand means it says that these two conditions need to be met in order for it to be considered, in order for this statement to be true. So a car needs to have greater than 20 miles per gallon, and then the variable AM, which is manual, needs to be equal to 1. Okay? Alright, so this is a way for you to check multiple conditions at once. Okay, so let's actually do this. And so I'm going to say mpg underscore am1 df. And one could argue it could have been just like a mod too, but just so it makes more sense. Okay, so I'm going to run this, and I can just do end row of mpg, tab it. It should run. It's 10 cars in that data frame. Okay, so that is great. That's fantastic. With that being said, this is a long enough video. Let's stop it here. Thank you.